I'm Kevin Robertson, a program manager and surface treatment engineer at Arizona DOT. It is my pleasure to welcome you to the sixth session of the virtual National Pavement Preservation Conference. This session is focused on pavement recycling and includes presentations by Steve Cross, Todd Gosner, Jason Walensky, and Don Matthews. Steve Cross is a professor of transportation engineering in the School of Civil and Environmental Engineering at Oklahoma State University. He is active in the Asphalt Recycling and Reclamation Association, ASCE, ASTM, and the International Society for Asphalt Pavements and the Association of Asphalt Pavement Technologists. He received an award for excellence in cold in-place recycling from ARRA in 1999. I'm pleased to turn over the program to Steve Cross. Thank you, Steve.
Steve Cross, that's one of my old biographies. I recently retired from Oklahoma State University. We're going to talk about project selection for hot and cold in-place recycling. So what I'm going to do is just give you a brief overview, be sure everybody understands what the hot and cold in-place recycling processes are. You'll get much more information on those in a few minutes. We'll show you some resources from where you can find some detailed information on what distresses these in-place recycling treatments can and cannot treat. And then we'll talk about a few special considerations as well. Basically, hot in-place recycling, it consists of a train of equipment. They're going to go down the pavement, and they're going to heat the pavement up and then loosen the existing pavement with a series of tines or milling heads. We're going to add a rejuvenating agent to try to restore the properties of that old oxidized asphalt. With some of the processes, we can add new aggregate or asphalt if desired to possibly improve the gradation or fix some mixed properties. The materials are all mixed, and then they're placed and compacted. HIR typically requires a wearing surface, although there have been a few treatments put down that have not required a wearing surface. And they're basically three broad categories of hot in-place recycling. There's surface recycling, which is the oldest one, which is just scarifying and recompacting the existing surface. Surface remixing is the process where it's surface recycling, but I can add new aggregate or asphalt. And surface repaving, you see a picture of it at the bottom. That's the third one, and it differentiates from the others in that it places an integral asphalt overlay at the same time, creating a thermal bond. So you not only perform a treatment of placement, you place the overlay at the same time. And then these can all be done in a single pass or multiple pass. And so with multiple pass HIR, I'm going to use a series of preheater and heater scarification units. And I'm going to, instead of heating and removing the pavement or loosening the pavement in one lift, I'm going to do this in a series of shallower lifts, typically anywhere from 2 to 4 lifts, anywhere from a 1/2 inch to 1 inch in total thickness. And this allowed me to go deeper, do a deeper treatment. Typically it's 2, but they have gone up to 3 inches. And by taking the pavement off in layers, I can do this without overheating the pavement. I use a series of tunnel heaters, or I pick the material up and place it over the top of the second unit. And that's how I keep the material hot. And then the material is then picked up and placed with the paver. And just like the other processes, it's more than likely going to require a surface course. So that's a real quick overview of HIR. With cold in-place recycling, I'm going to take a recycling train. I'm going to run it over a distressed asphalt pavement. I'm going to mill that pavement up. I'm going to add a recycling agent to it. I'm going to place it back down, and I'm going to compact it cold. So it will go down with higher air voids than was originally there. So it will require a surface course of some type to protect it. Typically, I want to leave about 1 to 2 inches of asphalt below the recycled layer just to support the weight of the equipment. That equipment can be quite heavy, and I do not want it breaking through the pavement. We have had instances where if I have a very good quality and very uniform aggregate base, I can remove all of the asphalt. I just do not want to be jumping in and out of aggregate base. I want as consistent of a mix as I can. And jumping in and out of aggregate base will cause me problems with my recycling agent content. And cold in-place recycling works best on cracked pavements that are structurally sound, have well-draining bases. Cold in place recycling is done with what we call recycling trains. There's multi-unit trains and there are 2-unit trains. So a multi-unit train is a full width milling machine and a recycling unit or a processing unit. So we're going to mill the wrap. We're going to drop it over a scalping screen. The material will be screened. The oversize will run through a crushing unit and be added back through. Then the material will be dropped into a pug mill where it adds a recycling agent based on the mass of the material entering the pug mill. And these processes, the recycling agents, either emulsified asphalt or foamed asphalt. Then it's placed and compacted. It will require a wearing surface. Single unit trains work a little bit different. All the mixing takes place in the cutting housing. So they're going to control the top size of the wrap with the down cut and forward speed of the unit. The recycling agent's going to be added in the cutting chamber and it goes in volumetrically. It's based on the assumed unit weight of the material and the volume of the material being processed or the forward speed. And again, this one, the recycling agent's either emulsified asphalt or foamed asphalt. Just some general overview then. Hot and cold in place recycling, they're both pavement preservation techniques and can be corrective maintenance techniques as well. When I combine these with an asphalt overlay, which is often done, they can be classified as structural rehabilitation. Both processes, hot and cold in place recycling, have been successfully utilized on all functional classes of roadways. So they've been used from interstate highways to airports to low volume county roads. They've been successfully utilized in rural as well as urban locations. They are economical and sustainable. They reduce carbon dioxide emissions, reduce trucking, and reduced use of raw materials. So where do they fit in pavement management and on the PSI curve? Well, hot in place recycling is used up toward the top. Your pavement's probably showing some distress that wouldn't really be handled with just preservation treatment like seal coats or slurry seals. Then you fall into the range of hot in place recycling. If the pavement is deteriorated a little bit more than that, and you're in the mid-range, you're in the cold recycling or cold in place and cold central plant. And of course, ARRA also represents full depth reclamation, and that's something we're going to use down toward the end of a pavement's life when it's beyond the condition where we can do a simple repair on it. So as far as distresses and which one of these treatments might you want to use, the basic asphalt recycling manual covers all of this. It covers cold planing, hot in place recycling, cold recycling, and full depth reclamation. And in chapter 3 is kind of a general overview. We have a table in there that lists the typical pavement distress modes and how appropriate each one of the ARRA techniques are to give you some guidelines of whether you might be looking at an HIR or a CIR job. And this is in the BARM under table 3.2. It's in chapter 2. I realize this is it's too small for you to see. I just want you to know that it's there in some place that you could go look it up for more information. But as you dig deeper into the BARM, you get to the chapters on hot in place recycling. And table 6 talks about project selection. And there's a comprehensive table in there that lists conditions like surface defects, deformations, load and non-load associated cracking, and other distresses. And then it tells you as columns that list the 3 different hot in place recycling techniques and whether they can handle the distress, fix the distress, and the notes will tell you if not, whether they can mitigate the distress, and whatever else might be needed to use. So they describe the HIR subdisciplines and the distresses. There's also notes that are going to clarify if we can mitigate the distress or other actions are going to be required. Now, if you don't have a copy of the BARM, I can tell you how to get one, but I will be telling you in just a minute about our new webpage, which is roadresource.org. These tables are in roadresource.org. They would be under the treatment toolbox, and then you would select HIR to get this table. Bring up another page, and you would have to select pre-construction, and then it's under site selection, and there's a link to this table. Kind of in summary, HIR is most effective as a maintenance or minor rehabilitation process. It's going to treat distresses that are generally confined to the upper 1 to 2 inches of the existing pavement. It's not meant to express structural failures. And not all processes treat all distresses equally, but kind of as a rule of thumb, HIR can be considered almost any time you would consider using mill and fill or a leveling course with an asphalt overlay. Moving on then, kind of covering the same thing for cold in place recycling. ARRA puts this under a category of cold recycling that covers CIR and CCPR. And there is a similar table that you saw for HIR. This is table 10.1. List the conditions and list whether CIR or CPR can correct the distress. The notes will give you more information about whether it might just mitigate it or any other actions that might be required. And again, this same table is in the BARM or can be found at roadresource.org under the treatment toolbox. I need to go to CIR or CCPR, pre-construction, and then site selection. So some very detailed information in these two tables. So kind of a general overview then of CIR. These processors are really not suited to address major structural failures of the pavement, such as structural rutting, severe fatigue cracking, or base subgrade instability. They're not going to get down deep enough to get that. It's really meant to treat all non-load associated distresses and most structural distresses that occur in the top 2 to 5 inches of the pavement structure. And CIR really is an excellent treatment to mitigate transverse or reflective cracking. It's a very economical way to remove a lot of that existing crack. And the more that crack you remove, the less likely it's going to be to return. As far as other resources, we have a new webpage, roadresource.org. It's been out for a couple of years. This is the overview or the home page. There's an about section, and we're going to look at the treatment toolbox, and then my ARRA information is under the recycling section as well. But if I click on treatment toolbox, it's going to pop up and give me 3 options, which treatment is right for my road, and I can explore by pavement criteria or by pavement photos. And then there's a treatment resource center, and I'll find a contractor. If I decide to explore by pavement condition, I can come up at the top in those boxes across the top, and I can put in my pavement condition or PCI rating of the pavement. I can enter the primary distress. There's also a box for road type and surface type, but for my treatments, that really doesn't have an effect. I can work on any road type and any surface type. And once you put in the pavement condition and the primary distress, over on the left are all the treatments that are covered in the web page, and they will fade away, and the ones that stay there are the ones that you could consider for this distress. And if you clicked on one of those, it would take you to the Treatment Resource Center where you could find out more information. You can also explore by photo selector. I would warn you to be a little bit careful with this. It's kind of hard to tell exactly what's going on with the road by looking at a picture. But the photos are sorted by pavement condition. You find one that looks like yours, click on it, and it'll give you some options. You click on, in this one, if I were to say just full depth reclamation, if I were to click on it, it would take me to the Treatment Resource Center under full depth reclamation where I could find more information. That's the Treatment Resource Center page. The green ones and the yellow ones on the far right are mine. And if you click on those, they will take you to basically an abridged version of the basic asphalt recycling manual. As far as some specifics then, a couple things to keep in mind that HIR and CIR, they're not going to get down deep enough. They're not going to fix base problems, subgrade issues, or drainage problems. One of the questions that comes up a lot of times is fatigue cracking, and minor fatigue cracking is generally okay. They can be treated well with these treatments. It's an in-place recycling process, so I need to know what's there. So you really need to cut cores or do some other type of exploration and find out what you have. I want to verify that I have sufficient thickness to recycle the pavement to the planned thickness. So it's a good idea to have a minimum of 1 and hopefully about 2 inches of asphalt below the recycling depth to support the equipment. I want to examine those cores for lots of things. Presence of stripping, how thick the cracks might go, but I also want to look for paving fabrics and excessive seal coats. So I want to be sure that if I'm doing HIR that there are no paving fabrics within about 1 inch of the planned recycling depth. The HIR simply cannot recycle paving fabrics. Paving fabrics can be recycled with CIR. It uses a milling machine, just like a mill and fill operation. But the contractor needs to know that it's there. He needs to know where it is. And he's probably going to have to add some extra people to his crew to either remove the shredded fabric off of his scalping screen and pick the larger pieces up out of the recycled mat. But it can be recycled in CIR, but not HIR. Existing chip seals or slurry seal coats, they can be an issue with HIR, but not usually multi-stage HIR or CIR due to the greater treatment depth. I'm mixing these seal coats in with more material and it's not that much of an issue. These seal coats can also inhibit HIR heat penetration. Excessive chip seals, slurry seals, they're high in asphalt content. With a thin treatment, they can cause an over-asphalted mix. So I have a couple of options. I can check it and see how it affects it with the mix design. If my strengths are a little low, I can add supplemental aggregate or do some other things to improve that. If it's going to bother with heat penetration or it's a real issue with HIR, I can simply mill it off prior to HIR. And then finally, rubberized asphalt mixes, they can be an issue. So it depends upon the type of rubberized asphalt you have, and you might need to just check with your local contractor as to whether this can or cannot be done. Utilities, they're always an issue, manholes and vaults, but they're really no different for CIR than any mill and fill project. We want to be sure we locate them, and then we want to lower them or work around them some other way. With HIR, lowering the utilities is not always necessary because the tines are spring-loaded and they'll ride up over them, or you can raise the small milling heads. And then last, occasionally we hear with HIR, if you're concerned about methane gas or something in some of the vaults or manholes, you might want to check those before you run the HIR unit over the top of them. I know that was quick, but I really wanted to point you to where you could find other information. Would direct you to our webpage, Road Resource First. And if you would like a copy of the BARM, this is how you can get in touch with me and I'll see if I can get it to you. So with that, that concludes my talk. Thank you very much.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.